Hi everyone. Today let's see the quantum mechanics, the basics of the quantum mechanics. In classical mechanics, we know that wave and particles are different phenomena. We know that two different phenomena that is called wave and particles. Both are separate characters. Moving electrons only have wave character or particle character. They should be mixed or independent. The next page, we can see next page. De-Broglie experiment is said moving electron has dual characters. It can behaving as wave as well as a particles. De-Broglie equation becomes for particle E equal to mc square. For wave E equal to h nu. Come to next page. It is assumed that De-Broglie wavelength lambda given by expression lambda equal to h upon p. Here h is the Planck constant, p is the momentum of the particle. Next, Eisenberg experiment. For any particles that rotating, it is impossible to determine position and momentum simultaneously at the same time. But in quantum mechanics, there is no distinction between wave and particles. The system is described by a mathematical function. It is called a wave function. It is denoted by psi. The next page. Psi is the wave function of state of the system. The wave function psi, the function of the coordinate and time. Psi or the t coordinate are equal x, y, z is the three direction, t equal time. The Schrodinger derived a second order differential equation for wave motion of electron, wave propagating in three dimension x, y, z in space. Next page. Schrodinger given two differential equation. First one is time dependent. It means there is a function of the time. Second one, time independent. Here we will concern only time independent Schrodinger equation. We can see the next page. That is d square psi upon d x square plus d square psi upon d y square plus d square psi upon d z square plus 8 pi square m upon h e minus v psi equal 0. Here psi is the wave function and d square is the state of the system. Here x, y, z is the three position of the coordinates. Move on the next page. Here h is the Planck constant, m is the mass of the electron, e is the energy, v is the potentially inert, psi is the wave function. This equation called Schrodinger time independent equation. Move on the next page. The next page. This equation gives several solutions and we get several values of the psi, out of which only few some values of psi are acceptable and valid, which is satisfying following conditions. Let's see. First condition, the psi should be single valued. It means it should have one definite value at a particular point. Move on the next page. Second condition, the psi should be continuous, but there should not be sudden changes in its value. Third condition, the psi must be finite over the space d dou that the electron occupy. It means there is the probability finding the electron in that space 1. So it should be finite, it can't be infinite. On the next page. Fourth condition. The fourth condition tells us the psi must be normalized. Why? Because the probability of finding the electron in space must be unity. So psi must be normalized. On the next page. These values are called eigenvalue. Eigenvalue equation h cap psi equal E psi. Here h cap Hamiltonian operator, psi eigenfunction, E eigenvalue. This is basic of the quantum mechanics.